Welcome. Welcome to the fourth lecture of probability theory. Till date, we have seen many of the things. We are trying to reconcile it in a tabulated form. I have put all the cases with different formulas to just compile the things which we have already seen. If you put it in a tabulated form, it may look somewhat like this. Just try to understand it. You don't have to mug it up. It is not needed at all. Just view it step by step. The first case is probability of occurrence of at least A or B. Here two words are important. One is at least and second is or. Whenever at least is used, always the connector is or. Okay. Since it is or, always we are talking about union. So probability of A union B is required for sure. Okay. There might be two different cases whenever you talk about union. Events are mutually exclusive and events are not mutually exclusive. What will happen? Which formula is to be used when the events are mutually exclusive? As we know that mutually exclusiveness means two events doesn't happen simultaneously. Or in other words, you can say it like this even, that if happening of one event simply discard possibility of happening others, those events are called mutually exclusive. Right? Okay. In that case, if you put some light in set theory approach, mutually exclusive means two different events. There is nothing common in between of those two. So naturally, in that case, A intersection of B will be null, or you can say it is pi. Okay. So probability of A intersection of B will go off, which will be 0. So naturally, the formula will be reduced to probability of A union B is nothing but sum of individual probability. So probability of A union B, which is equal to probability of A plus probability of B. What happens when they are not mutually exclusive? Means happening of one simply doesn't discard probability of happening others. That means there is something common in between of those two. That means A intersection of B is not phi. That means there is something common in between of those two. Naturally, that part is to be reflected in formula. In that case, probability of A union B is probability of A plus probability of B minus probability of A intersection B. Perfect? Okay. The second case, probability of occurrence of both A and B. Till now, we have only seen the addition formula. So what can be the case using addition formula? Okay. Here the word used is both. Whenever the word both is used, connector is always and. Since connector is and in a set theorematic approach, it would be intersection. So our intention is to get probability of A intersection of B. Just observe the last formula where probability of A, probability of B, probability of A union B and probability of A intersection of B. All these four components are there in that formula, right? Okay, just make some left hand side, right hand side process. Look, in a previous formula, probability of A intersection of B is on right hand side, probability of A union B is on left hand side. Just replace them. Probability of A intersection of B, if you just take it on left hand side, it will be positive. Fine enough. If you just take probability of A union B from right hand side to left hand side to right hand side, it will be negative. So that would be an altered formula. Probability of A intersection of B is probability of A plus probability of B minus probability of A union B. The third case, probability of occurrence of A and not B. Probability of happening A but not happening B. That means what we are talking about, B complement. So again the connector is and. Since the connector is and, we are talking about intersection. So it is probability of A intersection of B complement. You just think of, just have an idea of that Venn diagram. In that Venn diagram, all the points which are in A but not in B, which part may come? This is the first part. First part means probability of A intersection of B complement, and this is nothing but probability of A as a whole minus a common area probability of A intersection of B. So probability of A intersection of B complement is probability of A minus probability of A intersection of B. Is it clear? The fourth case, probability of occurrence of B but not A. That means it would be probability of A complement intersection of B. It should not be in A but it should be in B. Just think of which area may come with the Venn diagram. Right hand side, that comes to the whole B minus a common area. So it would be probability of B minus probability of A intersection B. Probability of non-occurrence of both. Look, the word here is non-occurrence. And another word used is both. Both means connector event. So it is nothing but intersection of not occurring A, not occurring B. That means they are complement. So probability of A complement intersection of B complement. This can be rewritten as 1 minus probability of whatever left hand side is there, the whole complement. So it would be A complement intersection of B complement, the whole complement. Okay, just open the bracket. A complement becomes A. Intersection complement becomes union, and B complement becomes B. Actually, it would be 1 minus probability of A union B, where A union B is nothing but the whole complement of A complement intersection of B complement, which is on the left hand side. The another case is probability of non-occurrence of at least A or B. Look, the word used here is at least. Connector is or. Since connector is or, it will be converted to union. Okay. So our intention is to get probability of A complement union of B complement. This can again be rewritten as 1 minus probability of whatever left hand side is there, its whole complement. That means A complement union of B complement complement. Open the bracket. A complement becomes A, union complement becomes intersection, B complement becomes B. So this can be rewritten as 1 minus probability of A intersection B. These are the formulas which you can use it directly without giving any of the proof, because it happens very naturally, and these are the basic notational formulas, right? Okay, let us have some of the examples using all these formulas. Let us suppose probability of A is given to you as 0.25, probability of B is given to be 0.15, probability of A union B is given to be 0.30. And our intention are to get values of probability of A intersection of B, probability of A intersection of B complement, probability of A complement intersection of B, probability of A complement intersection of B complement, and probability of A complement union of B complement. Look, all these formulas are nothing but this we have seen it in the case studies, right? In these cases, all these formats were there. First of all, try to put it in a tabulated form. If you put it in a tabulated form, row-wise, it is event A, column-wise, event B. Naturally, the first row would be probability of A, which is given to be 0.25. The next row would be probability of A complement, which is complement of A. Complement of A is 1 minus probability of A. 1 minus probability of A means it is 0.25, which comes to 0.75. Similarly, if you just go column-wise, probability of B is 0.15. The next column would be probability of B complement, which is 1 minus probability of B. Probability of B is 0.15. So 1 minus 0.15 is 0.85. Okay, now all these corners are made. Now think of something which is in an inner part, or you can say a middle part, right? Okay, the first case, a junction of a row and a column, it's probability of A and probability of B. In a junction, it would be probability of A intersection of B. Similarly, if you just shift right hand side, it is point is in junction of probability of A and probability of B complement. So probability of A and probability of B complement means that particular value would be probability of A intersection of B complement. Similarly, it would be probability of A complement intersection of B. And the fourth one, which is in junction of probability of A complement, probability of B complement, comes to probability of A complement intersection of B complement. Now, how to get all these four values, that we know it quite well, right? We are using the formulas now. Probability of A intersection of B, as we have seen it in the case studies, probability of A intersection of B can be found as probability of A plus probability of B minus probability of A union B. All these values are known to you, it is already given to you. 0.25 plus 0.15 minus 0.30, which comes to 0.10. This would be the required answer. The second case, probability of A intersection of B complement. Event A occurs but not B. That was the idea. This can be found as we have seen it earlier, that probability of A minus probability of A intersection of B. Now look, probability of A is already given to you, and probability of A intersection of B, which you found just now in the first case, which is 0.10. So make a difference of those two, probability of A, which is 0.25, A intersection of B is 0.10, which comes to 0.15. And this will be an ultimate answer. Similarly, probability of A complement intersection of B. A doesn't happen, but B happens. Occurrence of not A, but B, which is nothing but probability of B minus probability of A intersection B. All these two values are known to you. 0.15 minus 0.10, which comes to 0.05. The next case is probability of A complement intersection of B complement. We have seen it, which is nothing but 1 minus probability of A union B. A union B is given to you, which is 0.30. So it is 1 minus 0.30, which is 0.70. This can again be reapproached. This can be thought of like this even, that it is nothing, since it is an intersection, it is probability of A complement minus probability of A complement intersection of B. Again, that is possible using the same case studies. 0.75 minus 0.05, which is 0.70. Or similarly, this can be approached as probability of B complement minus probability of A intersection of B complement, which is 0.85 minus 0.15, which comes to 0.70. Look, in each of the case, you are getting 0.70 as an answer. So answer is unique. Any one of these three different approaches can be used. You don't have to bother about all the threes. Any one of these three different approaches can be used. Ultimate answer is 0.70. That is what the intention is. Similarly, the next one, probability of A complement union of B complement, which is nothing but 1 minus probability of A intersection B, as it is shown in the tabulation. 1 minus probability of A intersection of B is known to us, which is 0.10, which we have found it in the first case. So it comes to 0.90. This can again be reapproached as, since it is union means probability of A complement plus probability of B complement minus probability of A complement intersection of B complement. All these values are known to you. Just put it again, what you will get is 0.90. Look, in both the cases, answer remains same, means answer is unique. One can approach it in any one of these two different ways. That is fine. You have to use any one of these two, not the both. Any one is sufficient. Is it clear now? Okay. Let us add one more level of complexity in example. Here it was directly given to you that probability of A is something, probability of B is something, probability of A union B is something. Now, if you just take some real life situations, in that case data would not be directly in form of probability of A, B and A union B or A intersection of B. Naturally, it would be a little different. Let us see how it works. Let us suppose probability of getting a contract A is 0.25. Probability of getting a contract B is 0.15. And the probability of getting at least one contract is 0.30. Now calculate the probability of getting both the contracts, probability of getting contract A only, probability of getting contract B only, the probability of not getting both the contracts, probability of not getting at least one contract. Look, first thing is to be done in this type of examples are you have to put every information in a notational format. Let us suppose to get a contract A is event A. Getting a contract B is, let us suppose, event B. Then what will happen if you put it in notational form? Probability of A is 0.25. Probability of B is 0.15. And the third information given here is probability of getting at least one contract. Look, in this case, word is at least. When you say at least means connector is or. Since connector is or, always it is associated with union. So probability of A union B is 0.30. Is it fine? The three informations are given to you. One is probability of A is 0.25, probability of B is 0.15, and probability of A union B is 0.30. Fine enough? Okay. These are the information which is given to you. Now concentrate it on what is required. Put it in a notational form. The probability of getting both the contracts. Look, word used here is both. Both means connector is. And since connector is and, if you put it in a set theory approach, it will be intersection. So probability of A intersection of B is needed. Fine enough. The another one. Probability of getting contract A only. What do you mean by this? Probability of getting contract A only, that means he will get only contract A. That means getting contract A but not B. Again, understand it deeply. Getting contract A but not B. Okay. How you will be notifying it? It would be probability of A intersection of B complement. Fine. Next is probability of getting contract B only. That means only B, not A. Okay. If you put it in a notational form, it comes to probability of A complement intersection of B. That is what it is needed. Next is the probability of not getting both the contracts. Not getting. That means it is complement. Both. Both means it is intersection. So A complement intersection of B complement, probability of this event is required. So probability of A complement intersection of B complement, that is needed. Fine enough. What is the next? Probability of not getting at least one contract. Not getting, that means it is in a complement form. At least word is used. At least means it is always a union. Connector is or is always a union. So probability of A complement union of B complement is needed. Is it fine? Okay. Put it in a tabulated form again in a similar way. Row wise it is event A, column wise it is event B. Probability of A is 0.25. So naturally probability of A complement would be 1 minus probability of A, which is 0.75. Column wise probability of B is 0.15, probability of B complement is 1 minus 0.15 comes to 0.85. This borders you have fixed it. Okay. Now try to fill the inner part. Inner part again, the first case is in a junction of A and B. So it would be probability of A intersection of B. Junction of A and B complement becomes probability of A intersection of B complement. Junction of A complement and B becomes probability of A complement intersection of B. And the fourth one would be the junction of A complement and B complement means it is probability of A complement intersection of B complement. Right? Now let us try to get values. As we know that probability of A complement A intersection of B, which is as it was in a case study, probability of A plus probability of B minus probability of A union B. That means it is 0.25 which is given, 0.15 which is given, probability of A union B which is given to you, which comes to 0.10. And that is the ultimate answer. Similarly, probability of A intersection of B complement, as it is given in the tabulated form, A intersection of B complement means it is probability of A minus probability of A intersection B. All these two values are known to you. Probability of A is already given and probability of A intersection of B, we have just found it in the previous example, which is 0.10. So it is 0.25 minus 0.10 which comes to 0.15 and that becomes an ultimate answer. The third case, probability of A complement intersection of B. As we know that in the tabulated form it is probability of B minus probability of A intersection of B, which is 0.15 minus 0.10 which comes to 0.5. Similarly, probability of A complement intersection of B complement. You have seen it earlier, which is 1 minus probability of A union B. A union B is already given to you, which is 0.30. So it is 1 minus 0.30 which is 0.70. Or it can be reapproached as probability of A complement minus probability of A complement intersection of B, which is 0.75 minus 0.5 which comes to 0.70. Again, it can be reapproached as probability of B complement minus probability of A intersection of B complement, which is 0.85 minus 15 which is 0.70. Any one of these three approaches is to be used, not all these three. Is it okay? Similarly, probability of A complement union of B complement. We know it quite well. 1 minus probability of A intersection of B. A intersection of B, which we have found it in the first case itself, which is 0.10, 1 minus 0.10, which comes to 0.90. Since it is in a union form, they are in a complement form, but let us forget about that complement form. Let us suppose it is C and D only. Then probability of C union D, which is probability of C plus probability of D minus probability of C intersection of D. Now put it A complement as C and B complement as D. The formula comes to probability of A complement plus probability of B complement minus probability of A complement intersection of B complement. All these values are known to you, 0.75, 0.85, 0.70. Put it in a notational format and ultimately what you get is 0.90 and this is our ultimate answer. Any one of these two approaches can be used. It's not like that this approach is correct and this is not correct. Both of them are giving you the same unique answers, so both of them are correct. You can approach your answer with any one of these two ways. Is it clear? Let us have one more example. In a certain college, 25% students failed in Arabic. 15% students failed in Bengali and 30% students failed in at least one of the subjects. Okay, a student is selected at random. Calculate the probability that he failed in both Arabic and Bengali, he failed in Arabic only, he failed in Bengali only, he passed in both Arabic and Bengali, he passed in at least one of the languages. These are the different probabilities which we are likely to get out of the given information. Okay, first of all, in probability, what I would recommend would be just read your question twice. First time you will get the information, second time just think of it, be inside the example. Example itself will speak something out of it. In a certain college, 25% students failed in Arabic. Look, there are two languages what we are talking about. One is Arabic and second is Bengali, right? Okay. Let us suppose event A. Look, information is given in form of failed in Arabic, failed in Bengali. That is right? Okay. So naturally, in this case, our event which we are supposing should be in form of failed. Fine enough? So whenever we talk about pass, it would be in a complement form. Just keep it in mind. Okay. Here, 25% students failed in Arabic. Okay. So let us suppose event A is student failed in Arabic. Is it okay? Let us suppose event B is student failed in Bengali. Fine enough? Okay. Now, what would be probability of A? Probability of A would be 25%. Is it fine? Probability of B would be 30%. Is it fine? Fine. Probability cannot be in form of percentage. Naturally, it should be some value which should not have any bearing, which should be independent of all the measurements or measurement of units. You can say that percentage is to be removed. When I say 25%, then if I just want to remove that percentage, what should one do? Simply divide it with 100. So 25 divided by 100 comes to 0.25. So probability of A, means probability of student failed in Arabic would be 0.25. Similar logic if you apply to Bengali, 15%, eliminate that percentage. To eliminate percentage, we have to divide it with 100. So 15 divided by 100 is 0.15. So probability of B is 0.15. The third information, if one is interested in putting it in notational form, what should be the notation? 30% students fail in at least one. Look, the word used here is at least. When I say at least means or. What do you mean by or? Or means it is union. So this probability of A union B is 30%, eliminate percentage, which comes to divided by 100. So it comes to 30 divided by 100, which is 0.30. So these three informations are given to you. Probability of A is 0.25, probability of B is 0.15, and probability of A union B is 0.30. Fine enough. Our intention is to get first one. He failed in both Arabic and Bengali. Fine enough. Connector is and. Since connector is and, if you put it in a set theorematic approach, it would be intersection. So probability of A intersection of B is needed. Second, he failed in Arabic only. That means he failed in Arabic but passed in Bengali. Fine enough. That means our intention is to get probability of A intersection of B complement. The third one. He failed in Bengali only. That means he passed in Arabic. If you put it in a notational form, it would be probability of A complement intersection of B. That is what it is needed. The next one. He passed in both. Okay, now we are talking about passing. Passing is nothing but complement of failing. Okay. Past means non-occurrence. Both means connector is and. Since the connector is and, always what we are talking about intersection. So our intention to get this part is probability of A complement intersection of B complement. Right? The next one. He passed in at least one. Past non-occurrence. At least means any one of. Any one of means connector is or. Since connector is or, we are talking about union. So probability of A complement union of B complement, that is what it is needed. Now this many things are needed using all these three information. But let me put it in the notational form that will make it clear. Again, putting it in a tabulated form. Probability of A complement in row-wise format, probability of B and probability of B complement in a column-wise format. So naturally, the inner part would be the junction of A and B becomes probability of A intersection of B. The junction of A and B complement becomes A intersection of B complement. Junction of A complement and B becomes probability of A complement intersection of B. And the fourth junction would be against A complement and B complement, so it would be probability of A complement intersection of B complement. Is it fine? Now, to get all these values, the formulas which we have seen in a tabulated form are to be used of. Look at probability of A intersection of B. How you will get it? You know it quite well now that probability of A intersection of B is nothing but probability of A plus probability of B minus probability of A union B. All these three values are given to you. 0.25, 0.15 minus 0.30, which comes to 0.10. Fine enough? Probability of A intersection of B complement, which is nothing but probability of A minus probability of A intersection of B. These two values are known to you. 0.25 minus 0.10 comes to 0.15. The third case, probability of A complement intersection of B, which is probability of B minus probability of A intersection of B, which is equal to 0.15 minus 0.10, which comes to 0.05, which is as simple as that, and which is our ultimate answer. The fourth one which we require is probability of A complement intersection of B complement. This can be approached in three different ways. One of the approaches is 1 minus probability of A union B, which is 1 minus 0.30, which comes to 0.70. That is one way. Or this can be approached as probability of A complement minus probability of A complement intersection of B, which is both these values are known to you. Probability of A complement is 0.75, probability of A complement intersection of B, which we have found just now, which is 0.5. Make a difference of those two, which comes to 0.70. Third way which we can approach would be probability of B complement minus probability of A intersection of B complement. So again, all the values are known to you. 0.85 minus 0.15, which comes to 0.70. Is it fine? Okay. Last one. Probability of A complement union of B complement. Again, this can be done in a two different way. Probability of A complement union of B complement, which is 1 minus probability of A intersection of B. Look, A intersection of B, which we have found it in the first example itself, which is 0.10. So 1 minus 0.10, which comes to 0.90. Or the formula can be approached in a different way. Probability of A complement plus probability of B complement minus probability of A complement intersection of B complement. Look, all these values are known to you. 0.75, 0.85, 0.70, which comes to 0.90. So both of them are generating the same answer, or you can say it's a unique answer. So both the methods are correct. Any one of these two methods is to be used. Is it clear? Have you noticed one thing? Last three examples were the same one. In the first example, only probability, directly probability was given to you. Probability of A is 0.25, probability of B is 0.15, and probability of A union B is 0.30. That was fine. And we have to get all these different forms. Fine now? Okay. In the second example, again things were in form of probability only. Getting a contract, 0.25. Getting a contract B, 0.15. And the third case was at least 1, which is 0.30. Means some liquid form of data was given to you and you have to notationalize it, or you can say you have to put it in a notational format, and then after you have to get the answer. That was the second case. And the third case was the things were given in form of percentage, so we have to convert it in the form of probability, put it in a notational form, and then after whatever probabilities were required, you have to get all those probabilities. All the three examples were same, but they were with a different approach. Example asked in the sense the given examples, given problems were with a different approaches. Now you can do any damn example of a probability as far as union and intersections are concerned. Right? Let us have some more. A bag contains 3 black, 4 white and 5 red balls. One ball is drawn at random for find the probability that it is either a black ball or non-white ball. Fine enough. The second one. It is either a white ball or non-red ball. Fine enough. It is either a red ball or non-black ball. Fine enough. Understood? Again, as I said it earlier, just reread the whole example. The second time while you are reading the example, reading the problem, that problem will speak itself. A bag contains 3 black, 4 white and 5 red balls. How many total number of balls are there? 3 plus 4 plus 5. 5 plus 4 is 9. 9 plus 3, 12. In a bag there are 12 balls. Fine enough? Put it in your mind. One ball is drawn at random. Find the probability. One ball is drawn at random. Exhaustive cases, total number of cases available. Actually, total number of balls are 12. One ball is selected. You have 12 different opportunities. Always your denominator would be 12. Fine enough? Put cursor. Keep all this information in your mind. Okay, now think of what is needed. It is either a black ball or non-white ball. Two words are there. One is black and non-white. Defined. Black means 3. Okay. Non-white. Non-white means it should not be white. It should not be white means it can be red or black. So that total would be 5 plus 3. It is 8. So in the first case, black ball, we are approaching, it should come from 3 balls. When I say non-white ball, it should come from the remaining 8 balls. Is it fine? Fine enough. When I say white balls are 4. So that should come from 4. Non-red ball. Non-red means it should not be red. It should not be red means may put a cross mark on 5 reds. Remaining quantities are 3 plus 4, 7. If from those 7 balls, 1 ball is to be selected. Fine enough. It is either a red ball or a non-black ball. Red ball. It should come from 5 or non-black. Non-black means 4 white, 5 red. It should come from those 9 balls. Is it fine? Now you have the whole classification with you. Fine enough. If you put it in a format now, notational format, things will be easier. Here the word used is either. Connector is or. Since connector is or, what we are talking about is it is union. Number of total balls, there are 12. Number of black balls are 3. Naturally, number of non-white, it should not be white, as I said it earlier, that those balls are 8. So probability of getting a black ball comes to 3 by 12. 3 by 12 is nothing but 3 is the favorable cases for getting a black ball divided by exhaustive cases, total number of balls, which are 12. So it will be 3 by 12. Probability of non-white balls. Non-white balls are 8, so it would be 8 by 12. 8 is a favorable cases for getting non-white divided by exhaustive cases, which are 12. So it would be 8 by 12. Fine enough. Our intention was either a black ball or non-white ball. Now this events are denoted as A and B. So naturally our intention is to get probability of A or B. Probability of A or B means A union B. Probability of A union B is probability of A plus probability of B minus probability of A and B. Fine enough. Probability of A, which you already have. Probability of B, which we have already have, 8 by 12. Now think of A and B. A and B means black ball and non-white balls. Black ball and non-white ball. In non-white balls, again, 3 black balls are there. So probability of A and B becomes 3 by 12. So this comes to 3 by 12 plus 8 by 12 minus 3 by 12. And if you take a simplification, it comes to 8 by 12, it comes to 2 by 3, and which is what? 67. Is it clear? Let us have second example. Our intention is to get probability of white ball or non-red ball. Fine enough. Total number of balls are 12. Number of white balls are 4. Number of non-red balls are 7. Fine enough. Probability of white ball 4 upon 12. It is as same as we have seen it in the previous example, right? Probability of non-red. It should not be red. Red means all the total of all others, which are 7. So it comes to 7 by 12. When I say probability of A or B, which is nothing but probability of A plus probability of B minus probability of A and B. A and B means white ball and non-red ball. Look, the connector is and common is white. Common is white means that portion is to be deducted. So 4 by 12 plus 7 by 12 minus 4 by 12. While making a simplification, it comes to 7 by 12. And if you just take a numerical value, it would be simple. Now the third case. Number of total balls are 12. Number of red balls among it are 5. Number of non-black balls are 9. Probability of red ball, which is number of favorable cases divided by exhaustive cases. Number of favorable cases. How many red balls are there? There are 5. 5 upon 12. Okay. Probability of non-black ball. Non-black balls are 9. So probability becomes 9 upon 12. Is it okay? Now, probability of A or B. That means probability of red ball or non-black ball. So it would be probability of A plus probability of B minus probability of A intersection of B. Sorry, A and B. Okay. When the connector is AND. AND means it is always an intersection. Simple. So 5 upon 12 plus 9 upon 12 minus it is A and B. That means red ball and non-black ball. What is common in between of those two? Red balls. So naturally the probability of A and B would be 5 upon 12. Simplifying it, it comes to 9 by 12, which is 3 upon 4. Is it perfect now? One more example. A die is thrown. What is the probability of getting a number which is a multiple of 2 or 3? Another one. A number which is a multiple of 2 or 4. Look, it is a little tricky. Just think of it. What should one do? Total number on the surface of a die are 6, which any one number come on surface from 1 to 6. Probability of number being in multiple of 2. Which are they? 2, 4, 6. There's 3 different ways a number can be in multiple of 2. So it is 3 by 6, which comes to 1 by 2. Probability of number being in multiple of 3. How many ways you can get a number which is in multiple of 3? 2 different ways. 3 and 6. It comes to 2 by 6, which is 1.3. Since 6 is in a multiple of 2 as well as 3. So occurrence of 6, that is the occurrence of both the events. Hence, the probability of getting a number which is in multiple of 2 or 3 is, again, probability of A or B, which is probability of A plus probability of B minus probability of A and B, 2 and 3. That means 6. 6 means only one way you can get it. So this would be 1 upon 2 plus 1 upon 3 minus 1 upon 6. Simplifying it comes to 4 by 6, which is 2 by 3. So ultimate answer is 2 upon 3. Right? The another example, the second part, probability of number being in multiple of 2, you can get it as 2, 4, 6. Okay, 3 different ways. Favorable cases are 3, exhaustive cases are 6, which is 1 upon 2. Fine enough? Probability of number being in multiple of 4. Only one way you can get a number which is in multiple of 4, which is 4 itself. So actually one favorable case is, so it is 1 by 6. Since 4 is a multiple of 2 as well as 4, occurrence of 4 entails the occurrence of both the events, and hence the probability of getting a number which is a multiple of 2 or 4 is probability of A or B, which is probability of A plus probability of B minus probability of A and B. That means it is 1 half plus 1 upon 6 minus. Only one way you can get A and B, 2 and 4, which is 1 by 6, which comes to 1 half. Is it clear? One more example. A bag contains 30 balls numbered from 1 to 30. One ball is drawn at random. Find the probability that the number of the drawn ball will be in multiple of 3 or 5, 4 or 7. Two examples. It is exactly the same as you did it right now. But here numbers are different. It is 1 to 30 instead of 1 to 6. Let us approach it. Probability of the number being in multiple of 3. 3, 6, 9, 12, 15, 18, 21, 24, 27 and 30. These are the 10 different ways you can get a number which is in multiple of 3. Is it fine? So number of favorable cases becomes 10. Number of exhaustive cases, 30 balls are there. Any one of those 30 may come while drawing actually. So number of exhaustive cases becomes 30. It comes to 10 by 30. Fine enough? Probability of number being in multiple of 5. 5, 10, 15, 20, 25 and 30. These are the 6 different ways one can get a number which is in multiple of 5. 6 upon 30. Now you just observe it. Among these two, is there anything common? Since 15 and 30 are multiples of 3 as well as 5, the drawing of ball number 15 entails the occurrence of both the events, and hence the probability of getting a number which is in multiple of 3 or 5 is, again, connector is or means it is union. Union means it is probability of 3 plus probability of 5 minus probability 3 and 5. Fine enough. So it is 10 by 30 plus 6 by 30. Now 3 and 5. There are two cases, 15 and 30. So it would be 2 upon 30. That part is to be deducted. So 10 by 30 plus 6 by 30 minus 2 by 30. Simplifying it, it comes to 14 by 30, which comes to 7 by 15. Get a numeric value. That will solve the issue. The second part. In multiple of 4 or 7. Depart it, make it individualized. How many different ways? Let's get a probability of getting a number which is a multiple of 4 independently, 7 independently. First thing first, 4. 4, 8, 12, 16, 20, 24 and 28. These are the 7 different ways one can get a number which is in multiple of 4. So probability comes to 7 upon 30. A number which is in multiple of 7. 7, 14, 21, 28. These are the 4 different ways. So probability of getting a number which is in multiple of 7 becomes 4 upon 30. Now think of it. Is there anything common in between of these two? Yes, it is. There is a single entity which is common in between of those two, which is 28. Since 28 is a multiple of 4 as well as 7, the drawing of a ball number 28 entails the occurrence of both the events, and hence the probability of getting a number which is a multiple of 4 or 7 is probability of 4 plus probability of 7 minus probability of 4 and 7. 4 and 7 one can get it only one way, so it would be 1 by 30. So it is 7 by 30 plus 4 by 30 minus 1 by 30, which comes to 10 by 30. By simplifying it, it comes to 1 upon 30. 1 upon 3. Clear?